Welcome to this explainer, where we are going to completely transform your exam frustration into precise, high-scoring strategies by decoding the Cambridge Physics syllabus. I want you to think of your next physics exam exactly like a highly coordinated space mission launch. Seriously, hear me out. When you are launching a rocket, there is absolutely zero margin for error. Every single calculation, every single descriptive paragraph, every formula you apply must be absolutely perfect for a successful launch. If one telemetry reading is off, the whole thing crashes. Your exam is the exact same way. Today we are focusing on syllabus code 0625, specifically magnetism. But these strategies apply across the board, whether you are sitting for 0651, 0652, 5054, or even 9702. The difference between getting a B and securing that highly coveted A star in physics often comes down to how well you understand not just the raw concepts of magnetism, like forces between magnetic poles, induced magnetism, or the difference between soft iron and steel, but how precisely you can articulate them to the examiner.
So why do A star and B answers often look so incredibly similar at first glance? Let's dive right into this by looking at two typical Cambridge students taking on a real past paper question. We are going to call them Alex and Sam. Now, you probably know someone exactly like Alex. Alex is our walking, talking encyclopedia. When faced with a 4-mark question about induced magnetism, Alex's strategy is to completely overload the page with raw physics facts. We are talking about a massive, sprawling paragraph, practically dumping every single piece of knowledge they've ever learned about magnetic fields, domain theory, and electrons. It looks impressive, but there is zero actual analysis going on. It's just a wall of text. On the other side of the exam hall, we have Sam. Sam's problem is entirely different. Sam rushes. Sam looks at a complex multi-stage question, gets overwhelmed by the clock ticking down, and completely misses the specific command word requirements. Instead of a detailed explanation, Sam writes 2 quick bullet points that vaguely mention, "Oh, it attracts." Now here is the kicker. Both of these students confidently leave the exam hall thinking they absolutely nailed that question. They high-five their friends thinking they've got the marks in the bag. But when the examiner's red pen comes out, the reality is harsh. Alex, despite writing a whole novel, gets 2 out of 4 marks. And Sam gets just 1. The brutal truth is that the difference between a B and an A star isn't just knowing raw physics facts. It is about executing the precise analytical methodology that examiners are desperately looking for.
Today, we are breaking down the exact step-by-step playbook you need to master magnetism and systematically score top marks. We're going to cover Section 1, the Magnetism Exam Trap, Section 2, Core Magnetic Principles, Section 3, Material Matchup, Section 4, the Method Mark Strategy, and finally, Section 5, Crucial Examiner Warnings.
Let's jump straight into Section 1, the Magnetism Exam Trap, Precision over Breadth. Here is the absolute core of our strategy reveal. To succeed in these exams, you must hit 3 distinct cognitive domains, proving to the examiner that you understand the underlying causal relationships. The principal examiner reports are crystal clear about this year after year. You are being assessed on knowledge and understanding, which is recalling your basic definitions, but you're also assessed on application, which means using those facts in a totally novel scenario they throw at you. And finally, analysis, where you have to break down complex data. If you write like our friend Alex and only give knowledge, you are literally capping your maximum score no matter how many pages you fill. To fix this, top students use a specific structure. They don't just write, they decode the command word, and then they apply the PEEL framework. That stands for point, evidence, explanation, and link. Let's do a quick interactive check right now. I'm going to give you 30 seconds on the clock. Look at how you structured your last past paper answer. Did you make a clear point? Did you back it with physical evidence? Did you provide the explanation? And did you link it back to the question's core command word? The clock is ticking. 30 seconds to honestly evaluate your own writing style. If you aren't using PEEL, you are leaving marks on the table. Before we continue, subscribe to our YouTube channel, Ace the Exams, at @AceExams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving right along to Section 2, Core Magnetic Principles, the Arsenal.
Let's start building your analytical toolkit with a concept that consistently trips up students in the exam hall. Principal examiner reports explicitly warn that candidates confuse this key terminology, so you must always define it clearly before using it in your extended responses. Induced magnetism is the absolute classic trap for a student like Sam. Sam usually writes something vague like, "the metal becomes a magnet." That is a 0-mark response right there. The precise A-star execution, utilizing our physics success blueprint requires you to state that a magnetic material temporarily becomes magnetized when placed in a magnetic field. Do you see the difference? By starting your answer with this crisp textbook definition, you instantly secure those knowledge marks. Then, using the Peel framework, you move on to apply it to the specific setup shown in the diagram. We are transforming those red pen marks into green check marks right before your eyes. You define the parameter perfectly, and then you apply.
Furthermore, you must clearly establish how the forces between magnetic poles act, linking the raw concepts to their actual effects in the real world. It is simply not enough to just write opposites attract and hope for the best. You must explicitly state the causal relationship. You need to say, like poles repel, unlike poles attract, and this force is a non-contact force mediated by the magnetic field. Imagine a question asks you to explain the movement of a suspended magnet when another magnet is brought close to it. Let's execute the Peel framework live. Point: the magnet moves away. Evidence: because the north pole of the handheld magnet is facing the north pole of the suspended magnet. Explanation: like poles repel due to interacting magnetic fields. Link: therefore, the resulting force causes rotational movement away from the source. Boom. 4 marks, beautifully structured, impossible for the examiner to ignore. That is the physics success blueprint in action.
Now we enter Section 3, Material Matchup, Temporary versus Permanent.
Let's tackle the materials themselves. This is arguably the most common 4-mark question you will face in syllabus code 0625. When comparing soft iron and steel, you must identify both similarities and differences using clear comparative connectives to get full credit. Let's do a live rewrite of another bad answer. Alex's original answer was, soft iron is magnetic, steel is magnetic. Steel stays a magnet for a long time, iron loses it. It's factually sort of true, but horribly presented. To transform this into an A-star answer, we apply comparative connectives. Listen to how this sounds. While both soft iron and steel are magnetic materials, soft iron is easily magnetized and demagnetized, making it a temporary magnet ideal for electromagnets. In contrast, steel is harder to magnetize but retains its magnetism, making it a permanent magnet. Notice how those capitalized connectives, both and in contrast, physically force you to secure the analysis marks. It shows the examiner you are explicitly comparing, not just listing facts.
Notice how we use a visual story method to encode these comparisons, ensuring every claim is backed by solid evidence. The visual story method is brilliant for your revision. Picture a massive crane with an electromagnet picking up heavy scrap metal in a junkyard. It needs to turn on to pick the metal up and turn off instantly to drop the scrap. That's soft iron. Now picture a tiny compass needle that must always reliably point north no matter what. That's steel, holding its charge permanently. By linking the material properties to these visual stories, you naturally fulfill the examiner's mandate. You identify the similarity, the difference, you provide the evidence, and you draw a conclusion about their importance in engineering. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Welcome to Section 4, the Method Mark Strategy, Procedural Framework.
We are moving from theory into heavy practice now in our interactive workshop. This is where vital points are awarded purely for your procedural process. Look at the 5-step sequence on the screen. This standardized sequence is your guaranteed blueprint for systematically processing complex, multi-stage physics problems. Step 1 is to identify key elements, like scanning column headers in a data table or checking if the units are in normal Teslas or milliteslas. The top candidates execute this sequence systematically. Think of it as telemetry for your mission. Let's do challenge 1 right now, the data scan. Imagine a complex physics data table is in front of you. I am putting 60 seconds on the clock. Go! You need to scan the headers, find the anomalous result, and identify the core trend. Are the values increasing linearly or exponentially? Are the units consistent? You don't just stare blankly at the data. You actively identify the variables, apply the principles, and execute your working clearly so that the examiner can follow every single logical step. 30 seconds left. You must be aggressive with data interpretation. Time's up. Did you find the trend? That pressure you just felt is exactly what you need to manage during the real exam.
Within that sequence, you must deconstruct the given information into logical steps, solve systematically, and critically check your final answer for reasonableness. Let's move to challenge 2, find the flaw. I am going to read a flawed paragraph written by our rushing student Sam, and you have to spot the exact sentence that is hemorrhaging marks. Listen closely. The soft iron core is placed in the coil.
Current is turned on, it becomes a permanent magnet. The field lines go from north to south. Did you catch it? I'll give you a few seconds to think. Okay, time is up. The third sentence is the fatal flaw. It becomes a permanent magnet. Soft iron forms a temporary magnet, not a permanent one. This is exactly why you must evaluate your answers. Always ask yourself before you move on to the next page, does this conclusion perfectly align with the core physical properties of the material I just identified?
So, the crucial point here is that integrating your magnetism answers with other syllabus areas is a proven strategy for unlocking top-tier grades. This is all about cross-topic integration. Look at how concepts connect across the entire physics universe. Moving a magnetic field across a conductor induces an electromotive force, for instance. You're blending magnetism with electricity. The examiner's reports specifically note that students who can bridge the gap between chapters demonstrate the exact A-star evaluative thinking they're hunting for. Let's do challenge 3, speed writing. I'm putting a strict 30-second timer on the clock. You need to write one perfect, peel-structured paragraph connecting a moving magnet to induce voltage. The clock starts now. Remember your structure. Point, what is happening. Evidence, what is moving. Explanation, magnetic field lines being cut. Link, therefore voltage is induced. 10 seconds left. Keep writing, keep that structure tight. And pencils down. If you can execute that under pressure, you are ready for launch.
Finally, we reach Section 5, Crucial Examiner Warnings, the post-game analysis. Even with the perfect framework, you need to know exactly where past students have completely dropped the ball. This beautifully illustrates our core theme today. Principal examiner reports explicitly state that superficial generalized answers will not earn marks. Saying a magnet pulls things is way too vague. We are scientists, we must use the professional terminology of the discipline. You need to write exerts an attractive magnetic force on a ferromagnetic material. That is the exact level of precision required. Every single time you write a vague pronoun like it or they on your exam paper, I want you to mentally cross it out and replace it with the specific physics term. Don't say, it gets stronger. Say, the magnetic field strength increases. Precision is everything.
Avoid these top 3 mistakes by applying correct formats, using proper headings, and making sure your answer directly addresses the provided context. Let's talk about warning number 2. It is an absolute tragedy. Bad formatting. For example, if you are asked to draw magnetic field lines and your lines touch or cross each other, or you forget to draw the directional arrows pointing from north to south, you lose marks immediately. It doesn't matter if you know the theory, your execution failed. Warning 3 is ignoring context. Always apply your physics rules directly to the specific experimental setup provided in the prompt, rather than just vomiting out a memorized generic response you learned from a textbook. You have to answer the question in front of you, not the question you wish they had asked.
When dealing with complex texts and tables, your ability to extract relevant data and interpret relationships is just as important as your underlying physics knowledge. Let's look at the cheat sheet recap graphic on your screen and review the complete final system that guarantees top marks. Rule number 1, command word decoding. You must know exactly what the verb is asking you to do. State means a quick fact. Explain means you need the Peel framework. Rule number 2, Peel framework application. Structuring your point, evidence, explanation, and links so the examiner cannot possibly miss your logic. And rule number 3, the time management matrix. Allocating your minutes precisely based on the mark allocation of the question. Do not spend 10 minutes on a 2-mark question like Alex does, and do not spend 30 seconds on a 6-mark question like Sam does. Stick to the matrix. 1 mark generally equals roughly 1 minute of focused effort.
The next time you face a complex magnetism question, challenge yourself to step beyond mere facts and apply this precise analytical methodology to secure every possible mark. Will you be like Alex, pouring out a disorganized ocean of knowledge hoping something floats? Will you be like Sam, rushing frantically past the critical command words and losing easy marks? Or will you be the strategist, calmly deconstructing the question, extracting the data, and executing a flawless, Peel-structured response? Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. The choice and that A-star is entirely in your hands. It's time to launch your space mission. Keep executing with precision.